So starting us off here with Unit 1, Section 1, Parent Graphs, we're just going to do the first piece today. We're going to start with the first four, just basic graphs. The first one is a linear graph, y equals a to the x power. Y equals a to the x power. That a could be anything. Could be a number, could be a fraction, could be positive, could be negative. And then we could have other things added to this or subtracted to this. But for now, for your homework, it's going to look something like this. Let's take a real basic y equals 2x. If you want to graph that, y equals 2x, there are a number of ways. I'm going to show you the fallback way, the way you can always graph these types of graphs, all four of them, if you don't remember a shortcut or another way. The way you can always do this, what always works, is a t-chart. You can always plug in numbers and get points and graph it. So if we were to do that, I'm actually going to make an H chart to give myself some room to work here. So if I plug in the number 0 for x, 2 times 0, 2 times 0 is 0. And there I have my first point on my graph, 0, 0. Does that make sense to everybody? Now for this one, since we don't have a fraction or anything like that, you can plug in whatever numbers you want. The easiest ones, let's plug in 1. 2 times 1 would be 2. So I'd have the point 1, 2. And I could plug in negative 1. 2 times negative 1 would be negative 2. And there I have a couple points for my graph. I could keep plugging in other points. Put in 2, 2 times 2 would be 4. Put in 3, 2 times 3 would be 6. But again, with a straight line, once you get just like 2 or 3 points, you can see the general shape of the graph, and you can draw in the rest of the graph. Please draw your graph all the way across, top to bottom. Don't stop early. This is going to be important later on. Not so much right now, but important for work that we're going to do later. Now, that's kind of a quarter of our lesson. Go ahead and grab your homework packets and look at the very first homework problem. Number 1. Y equals 3 over 2x. So you've got a fraction there, but you can graph it the same way. My suggestion is, rather than picking negative 1, 0, and 1, pick numbers that are divisible by 2, so you don't end up having to graph a fraction. So if I was going to do that, I would pick x's like negative 2, 0, and 2, maybe 4 if I wanted to, and plug those in. So if I were going to do that, like put in negative 2, 3 halves times negative 2, I could do 3 times negative 2 is negative 6. Divided by 2 gives me negative 3. And that would be my first point. Negative 2, negative 3. Can you all finish graphing that? And do you all see why I picked those values and not negative 1, 0, and 1? Yes? Up and down is yes, side to side is no. How are we doing? Do we understand what's going on there? Go ahead and graph number 1 here. I'll give you 2 minutes here. Get that one done. Alright, so as you guys are going, go ahead and check your work up here. Should have gotten a straight line. Now, just because I've shown you one way doesn't mean it's the only way. If you remember how to use the slope to graph these, that is much faster than making the t-chart. I showed you the t-chart because you can always use that for any type of graph. But for a linear graph, once you find one point, like 0, 0, you can also use the slope and go up 3 over 2, up 3 over 2, up 3 over 2, and hit those points. Does that make sense to everybody? All right, any questions with the first one there? All right, so back to the notes then. Look at the quadratic graph, y equals ax squared. Again, this is the simplest quadratic graph. We're going to do more complicated ones later. For now, though, we're just going to have x squared with some number out in front. Positive, negative, fraction, doesn't matter. You're going to have something out in front there. But that's not really the slope for this. For a quadratic, you don't have a slope because it's a U shape. It's not a straight line. So instead, we're going to think of that a as kind of the vertical stretch, how quickly it goes up or down. So let's go ahead and graph y equals, how about something a little different than what you're going to get on the actual thing. Let's go with y equals, we'll keep this pretty simple, y equals 3x squared. Y equals 3x squared. So again, you can make yourself a broken t-chart or an h-chart. Here you can put in whatever numbers you want, but really only 3 of them are going to fit on this graph. -1, 0, and 1. Let's start with 0 again. 3 times 0 squared. So you're going to use order of operations, always. If you've forgotten what those are, they are here on your notes, order of operations, parentheses, exponents, multiplication and division, addition and subtraction, or grouping exponents, multiplication and division, addition and subtraction, in, again, for the multiplication and division and addition and subtraction in order from left to right. So here we're going to do anything inside the parentheses, which is just the number 0. Then we're going to do the exponent, so 0 squared, 0 times 0 is still 0, times 3, still 0. So there is 1.00. 3 times 1 squared. Do the 1 squared first. 1 times 1 is still 1. Times 3 gets you 3. So we've got the point 1, 1, 2, 3. I can also plug in the -1, 3 times -1 squared. Now, I put these parentheses in here to remind myself that I'm squaring whatever I'm putting in for x. That whole thing, including the negative. So -1 squared, -1 times -1 is +1. Is everybody good with that? -1 times -1 is +1. Times 3, 3. So I get -1, 3. Now, unfortunately, if I keep going, if I put in 2, 2 squared is 4, 4 times 3 is 12, and that's off my graph. So, as best you can, make this a U shape, not a V shape, and it's going to go up real fast here. Any questions there? All right, take a look at, on the homework, number 7. Look at number 7 on the homework. Y equals -x squared. Same thing as the one we were just doing, right? It's still a quadratic. It's got that squared on the variable. What's the negative out in front going to do? So So changing your answers to a negative, which I hear a few of you kind of describing it. What's happening to the graph when we put that negative in front of it? Yeah, it's all going to go down, which I think is what you were saying when you were saying it's going negative. Yeah. So go ahead and try this one. You're going to square the numbers first. Square the numbers first. So if you plug in -1, you do -1 squared, which would be 1, and then you're going to make it negative. So get a couple points here. This one you can actually fit a few more points on. If you pick x's, you could fit in -2, -1, 0, 1, and 2. You could fit all those points on this graph, and that would give you a much better idea of what this looks like. If you want to remind yourself, put the x in parentheses, that you're squaring whatever you're plugging it in and then making it negative. So go ahead and graph this as best you can. If you finish this one quickly, you are more than welcome to work on the other ones. Just be careful, check them as we go on, just in case I remind you of something you forgot if you've gone ahead already. Yeah, so you put the -2 in for x, you do -2 times -2, which is squaring it, +4, and then you're going to make your answer negative. So that, yes, because that negative happens after the square, unlike the -2 that you plugged in. So that's up to you. I would put the answer, yeah, either here or off to the side, wherever it makes sense to you, but your answer would be -4. Does that make sense? So you will already have done the squared. So you do -2 squared.
Yeah, I did it right here.
Oh. So if you already found 4, you don't need to write the square. You already used that. Does that make sense? So you don't have to write it the way I've been doing it up there, if that doesn't make sense to you. It's just a way of showing kind of your work, but if it makes sense, you go on ahead and just write the answer down as well. Yeah. But it is going to be negative for because of that negative. Okay, so in this one it's going to actually be -1 because you put the -1 in, squared just for 1, and then negative 0. Yeah, there you go. They would be negative because you can square the 1, it would be 1, but then that negative down in front gets applied at the end of the variable. Right. You square it first, and then you put that negative on there. All right, if you want to check your answer, I checked a few of yours as I was out there. Should get something that looks like this. Should be going down because of that negative. All right, back to the notes. Absolute value, y equals a times the absolute value of x. Here, we're back to the a being more or less like a slope, except absolute values always make a V-shaped graph. So we're going to look at that and make sure that we have the V shape, and essentially we're going to end up with two different slopes, one positive and one negative. So let's take just y equals, let's do one that's different than what's on your homework. How about 2/3? Y equals 2/3 absolute value of x. So if I want to graph this, same idea, I can make myself a nice little broken H chart, broken T chart. I can put in whatever numbers for x that I want, but notice that my fraction has a 3 on the bottom. So it's going to save me a lot of time. It's going to be a lot easier if I pick numbers divisible by 3. So let's take -3, 0, and 3 as our numbers here. 2/3 times the absolute value of -3. What does the absolute value of -3 become? Positive 3. Is everybody good? Absolute values, if you have a negative inside. So after you've done all the operations, an absolute value starts off just like a set of parentheses. Do everything inside. If your answer is negative, the absolute value makes it positive. So here, -3 becomes +3 times 2/3. The 3's will cancel out, or you can think of this as 2 times 3 is 6, divided by 3 is 2. No matter how you choose to do it, you should get a y value of 2. If you plug in 0, 2/3 absolute value of 0, that's still just 0 times 2/3 is 0. And then if I plug in 2/3 absolute value of 3, the absolute value of 3 is still just 3. Absolute value doesn't do anything to a positive number. But 3 times 2/3, then the 3's cancel out and I get a positive 2 again. Does that make sense to everybody? When I plot those points, -3, 2, 0, 0, 3, 2, do we see the V shape there? Can you see it coming down, hitting the bottom, going back up? If you have an absolute value equation and you don't see the V shape, plug in some more points until you can see it. Does that make sense? It should not be a straight line. You have to see that V shape. Once you've got the V shape, though, let's see, that would be the next point. You can go ahead and graph it. There are shortcuts for these. So this one, 2/3, you essentially have a slope of up 2 over 3 on one side and up 2 back 3 on the other side. But again, if you're at all hesitant about that, just plug in a couple points, get the general shape of the graph. All right, on to number 4. Exponential graphs. Y equals b to the x power. Y equals b to the x power. There's a reason it's b and not a. We'll talk about that later. For now, don't worry about it. Just know that it's going to be y equals a number raised to the x power. That number, for what we're doing right now, is always going to be positive. Let's take y equals 3 to the x power. So again, plug in whatever x's you want, but here don't put it in big numbers because you'll quickly end up off the graph. I'm going to leave a little space here. I'll put in a -1, and then a 0, and a 1, and a 2. So those of you that were in my Math 1 class 2 years ago, we hammered this. We went over it a bunch. The rest of you, hopefully your Math 1 teacher did the same for you. Anything to the 0 power is always the same answer. What is it? 1. Does that make sense to everybody? So 3 to the 0 power is 1. That's kind of our anchor point. That's the point that we're going to have in every single exponential graph that we're going to do today. And then the next one's pretty easy as well. 3 to the first power is 3. 3 to the second power, 3 squared is 9, and that's at the very top of our graph. So right now I have 0, 1. I have 1, 3. And 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right off the graph there. If I put the negative in, 3 to the negative 1 power, this always trips people up. We practiced this back in Math 1, but you didn't do necessarily a whole lot with it in Math 2, depending on your teacher. Hopefully we at least remember seeing it. We'll talk more about this later, but negative exponents are not going to give you a negative answer. They're going to give you a reciprocal answer. It's going to be 1 over 3. So what I want you to think of for now, for today's homework, when you have negative exponents, you're not going to have a negative answer. Your graph is not going to go below the x-axis. And in fact, the x-axis gets a special name here. That line that we don't go beneath is called an asymptote. And we'll talk more about those later. But for now, know that your exponential graphs are going to hug the x-axis. They're going to be right next to it until we hit those points, and then it's going to come up and make a nice L-shaped graph, like so. That's what we're looking for our exponential graph. All right. It always seems like 6th period doesn't quite have as much time as the other classes. We've got about 5 minutes left here. So that's all you need to know for the homework tonight. But flip your page over, and I've got a few quick things that I want to point out to you. Number 5, 3y minus 4x equals 0. That doesn't look like what we've been doing. But it's not bad. All you have to do is solve for y. That's what makes this look different, is it's not solved for y like the other ones. So here, if I add 4x to both sides, doing inverse operations, or inverse order of operations, 3y equals 4x, divide by 3, y equals 4/3 x. Now you can see that it's a linear equation. Plug in numbers divisible by 3, and you'll be able to graph that. Does that make sense to everybody?
Yes.
Or again, use the slope up 4 over 3. Number 6, V-shaped graph, right? But going down, upside down, absolute value because of that negative. You'll do the absolute value, then multiply by negative 1 over 4. It'll be upside down. 7 and 8, both quadratics. Which of those two is going to go down?
8.
8. 9, we did that one on the other side just a moment ago. 10 should be one of the easiest problems on your homework, but we always have issues with it. So real fast, a quick reminder, y equals a number. Y equals 2 is a horizontal line going through y equals 2. Y equals is always a horizontal line. X equals a number. X equals 3 is a vertical line going through x equals 3. You must know those. You need to memorize that some way, shape, or form. So is number 10 horizontal or vertical? Vertical. All right, I apologize that you've only got like 1 minute here. Normally I'll try to give you more time than that. Homework tonight that we'll go over tomorrow, 1 through 15. You've got a few of them knocked out already from what we did in class. Does anyone have any questions about what we went over?